The graph of the second derivative f double prime of a function f shown. Find the x coordinates of the inflection points of f. So we are given second derivative, okay, y equals f double prime. This is second derivative of a function. Now we need to find the x coordinates of the inflection points. So inflection points means the point where the concavity of a function changes from concave up to concave down or concave down to concave up. And since this is not the graph of the function, this is the second derivative function, we cannot find the corresponding y coordinates. Okay, inflection point means x and y coordinates. We are only asked to find x coordinates. So when we write down second derivative 0, that gives us candidates for inflection point. Okay, x coordinates obviously of inflection points. Inflection points. So we need to do a sign chart or interval test. So let me do over here. Looks like the graph is just smooth and going forever, increasing in both directions. So we got all real numbers as the domain. And let's see second derivative. Second derivative is 0 at 3 places: -2, 1, and 3. -2, 1, and 3. Now let's look at the sign of second derivative. On the left of -2, okay, on the left, the graph is above the x-axis. That means second derivative is positive here. From -2 to 1, this is below x-axis, so negative. Again, 1 through 3, below x-axis, negative. On the right of 3, it's above x-axis, means second derivative is positive, because this is the graph of second derivative. And we know that when second derivative is positive, the function is concave up on that interval. Concave down, concave down, concave up. Okay. Now we can see there were 3 candidates, but at 1, the concavity does not change. It's concave down, again concave down. So 1 is not the x coordinate for the inflection point. Only -2 and 3 are x coordinates of the inflection points because concavity changes. So the answer for this, x equals -2 and 3. There were 3 candidates, but this does not qualify because the concavity does not change.